So we're being asked to explain geometrically the significance of this statement here. Let's just focus in on what this statement is saying. It's saying that the magnitude of the vector a plus b is equal to the magnitude of vector a and b. Now, to help us with this, I just want to show you a scenario where it's not true. So on a graph, I'm going to draw the position vector O to A, and I'm going to label that as A. And I've got another vector here, which is I'm going to label B. So this line here represents the resultant of the two vectors A plus B. Now in this scenario here, we can clearly see that if I add together the length of that vector and the length of that vector, it's not going to be the same as that vector there. So for our situation here, we need to have the vectors, so this is going to be my vector A here, and this is my vector B here. They need to be in the same direction, because if I put those two vectors together like so, and I find the resultant of those two vectors, in this case A plus B, I can clearly see that the length of that line, the length of the whole line, is equivalent to the length of the blue line and the length of the black line. So the significance of the statement is that the vectors are pointing in the same direction. Ultimately, they're parallel to each other and pointing in the same direction. Okay, let's focus on the next question. So the difference between vectors m and n are such that. So it's more about understanding the wording. I've got a vector. I'm going to call this vector m. And I've got another vector n. And it says the angle between vector m and vector n is 30 degrees. So this is my vector n here. Now if I connect a vector between those two there, I can be careful about the direction of that. Let me just rub that out. Because if I point the vector in that direction there, okay, so I want to go from here to this point here, from this point here to this point here, is going to be m minus n. So we have the scenario which has been expressed in the question. Just going to move this down a little bit here. So we've been told that m is equal to 3, so I'll put that information on here. And this is equal to 6. And find the angle between the vector m and the vector m minus n. Well, this is going to be this angle here. Now we know this angle here is 30. So I know that the length of the side opposite the angle 30 is 6. I've got another length here of 3. Maybe I should work out this angle here using the sine rule, and then I can find this angle here, which is what I ultimately want. So the sine rule is telling us, let me just move this diagram out of the way a little bit. So I want the angle x, so I'm going to say sine x over 3 is equal to sine 30 over 6. So sine x is equal to a half sine 30. Therefore, x is sine to the minus 1 of a quarter which is 14.4775. So now to find the angle that I want, theta, I'm just going to subtract that from 180. So 180 minus 30 minus 14.4775. 0.47, blah, blah, blah. And that's going to give me 135.5 to 1 decimal place, or 136 to 3 significant figures. And the question wants it in 1 decimal place, so we'll rub that out there. Okay.